Hi, I'm Sammy Hasten. This is the Lab 1 draft for the Charge Tape Lab. The purpose of this lab was to show how neutral objects can become charged due to excess charge, and we saw that by having the two different tapes. And you would take your base tape and put it up to everyday objects, like I put it up to a water bottle, and it would attract to the water bottle, which shows that the water bottle has some positive charges because we found the tape to be negatively charged. And then we also determined an approximation of excess charge left on a charged piece of tape. So again, we found the tape to be charged with negative charge, and this was found throughout the lab, and I'll discuss this further later. And we calculated the excess electrons through Coulomb's law, which is E equals K, which is a constant for 1 over 4 pi epsilon sub 0, and then times Q1 times Q2 over R squared. Q1 and Q2 are the different charges, the two different tapes, and then R squared is the distance between the two. The two big physics principles discussed throughout the lab are that like charges repel and opposite charges attract, and this was evident through the different tapes going up to different objects as well as to each other. And the other one is just the conservation of charges, which is the charge transfer between objects. So a few observations throughout the lab was that the U-tape with the other U-tape repelled each other, which means that they do have the same charge. The U-tape was attracted to neutral objects. When I held the U-tape up to a calculator, it was attracted towards that as well as a water bottle. And from this, we did the pen test where I rubbed the pen on some fabric to make it negatively charged, and it repelled the U-tape. So from that, we can conclude that U-tape is negatively charged. In regard to the floating U-tape, the top U-tape can only float if the only two forces acting on it are the force of gravity and the electric force from the other U-tape in the y direction. Keep in mind that the second U-tape was directly below it, as they were attached to books to allow it to create the floating part. And then if you can look at the bottom right, you see a quick little visual of what the charges are looking like. So the top arrow, which is orange, is the electric force of the tape below it, and then the green arrow is the gravitational force experienced on the top U-tape. In regard to measurements and calculations, the tape mass was 0.0002 kilograms, the length was 0.20 meters, the float distance, which is the distance between the bottom tape and the top tape, that was 0.005 meters. It is important that you note an assumption, which is that the tape can be treated as a point charge, and this will help later with the calculations. And then the two first calculations I did was the electric force and the gravitational force. The electric force was found by the negative of the gravitational force because they are equal and opposite, and that comes out to be 1.96 times 10 to the negative 3 newtons for the electric force. The gravitational force was found by multiplying the tape mass by the gravitational constant, which is 9.8 meters per second squared, and that came out to be negative 1.96 times 10 to the negative 3rd newtons. And a few more calculations were needed for this lab. For a charge, that is the force for gravity times the float distance squared all over k, and this is the square root of that whole thing. That comes out to be negative 2.33 times 10 to the negative 9th coulombs. The excess electrons were found by multiplying negative 1 times the point charge over the electron elementary charge, and that came out to be 1.458 times 10 to the 10th electrons. The atoms on the surface was found by dividing the tape length by A, and that came out to 2 times 10 to the 9th atoms. And then the ratio of electrons to atoms was found by dividing the excess electrons by the atoms on the surface, and that came out to be 7.29 electrons per atom. Below here you see my code, and this can be looked more thoroughly at the link that will be attached. This slide shows the image from GlowScript for my model, as well on the right are just the constants that I already solved earlier in this presentation. In conclusion, I was able to visualize like charges repelling and opposite charges attracting. as well as the force from the tape and force from gravity, creating a net force of 0, which makes the top tape in equilibrium, showing it floating. And we were able to calculate the number of excess electrons as well as the charge of the tape because it was in equilibrium.